Hello, everybody out there listening. Today, we welcome to the podcast somebody who I've been trying to get on for a while now. He has a lot going on, so it was great to finally sit down and talk with him. He's currently going to school at Wayne State to pursue a degree in astrophysics. He is on a road that could actually take him beyond the confines of our tiny yet incredible planet. He is also the president of the Warren Astronomical Society and a very talented juggler and unicyclist. Before we start, I want to apologize again. We don't have video footage of the podcast. We seem to be having trouble with our editing software for some reason. However, what's really important is we have the audio, and boy, it should make your head spin. Certainly did mine. He has a lot to say, and I really enjoyed sitting down and talking with him, and I'm sure Joe did as well. So let's not wait any longer and give a warm welcome to the podcast to the unicycle cowboy slash astronomer slash human being, Jeff Macleod. What's up, man?
How's it going?
How you doing?
Doing all right. I'm excited to talk science.
Last time I talked to you, you told me you were going to school to be an astrophysicist,
Yeah, it's
and that's
super hard to
something
get out
you
here.
never hear. I have never heard that from anybody.
We're a small group at Wayne
Yes.
State, the physics majors, and we like to make fun of the engineering majors.
I bet you do.
Yeah.
It's just more of a risk? It's just
I don't know why people just don't like physics, and for some reason want to. I think the idea is that if you're an engineer, you're going to actually build something concrete
Right.
and real, and if you're a physicist, you're just going to think about things and
not do anything. Okay, yeah,
and I
for
think
sure.
the reality is just the opposite. If you're an engineer, you're probably going to get everything out of a book. You're going to be constrained by all the rules and regulations of whatever your field you go into, whether it be bridges or
Yeah.
and
Computers.
it's going to crush your creativity because you really have no say in what you are going to design.
Okay.
And as a physicist, I think you can actually do more. But
It's just
I just
more.
want the title. I just want to be able to say physicist. Doesn't that sound great?
It does.
Every day I get a little bit closer to mathematician.
Yeah.
There's
How
just
much
something.
longer you got?
Probably 2 years.
2 years?
Yeah.
How long have you been going for it?
Decided about 2 years.
Okay.
2.5 or
It's like
so.
a 4-year program.
Pretty much.
kinda.
Nobody gets out of Wayne State on time.
No.
Nobody.
And then it's probably a heavy load, right?
It's getting heavy.
Yeah.
My next semester is modern physics, which is all the special relativity and that kind of stuff. So that's going to be fun. Differential equations, which I hear just crushes a lot of people's soul. I'm super excited about it.
Yeah.
That's what I heard too. Yeah, it's one of the most
Like
difficult ones.
there was a point in my life where, I'll never know calculus, and now I'm through all of
I'm there.
calculus.
That's I've been stuck there my whole life.
Oh man, calculus is amazing.
Algebra too.
And that's because I get
Algebra too.
closer and closer to pure math. But and then some advanced astronomy. I don't even know what it is because I'm not worried about it. But
Right.
yeah.
Well, what would you be like? I always wonder that because like the astrophysicists that we hear about are like the Neil deGrasse Tysons and stuff, and Carl Sagan's, and those guys
Yeah.
are science communicators as well. Like what would you be
Yeah,
doing?
you don't really ever see the guys that are making the huge contributions unless you're watching, the Nobel Peace Prize ceremonies or something like that, which is just, the highest award that year. But there's so much that goes on every year that you don't hear about.
Right.
I like Neil deGrasse Tyson. I've heard good things and bad things.
Yeah, for sure.
I personally like him. I like that he will just blatantly attack flat earthers or
Sure.
conspiracy theorists without any disregard for how he says it, and I like that. But I don't think he really has many sizable contributions to science in his field. I know he does, and he runs the Hayden Planetarium. He does a lot of great things, but in the field, it's like publish or perish.
Nothing like breakthrough, like
No,
no.
and certainly not to the extent of Carl Sagan. Like
Right.
he's always compared as being the next Carl Sagan, and he's definitely Carl Sagan in to the public
Yeah.
and what he does for science. But in terms of his actual contributions, Sagan was
Right.
Sagan did a lot.
Yeah, like what would be considered a contribution, and what would be considered like the Cosmos Special? Is that
That does not advance science
Exactly,
at all.
exactly.
That's popularizing science, which is a great thing that we need more of, but
Right.
it's certainly not the forefront.
Right.
I mean, the forefront is even further away than people think it is.
Yeah, I would imagine so.
Which is one of the scary things about going into science, because it's now so specialized that just to know enough to know what you shouldn't study, because you can get a novel idea of, I want to study how, if an electron moves through this type of medium, what will happen? And then you take all of these courses and you find out, well, that was done in the 60s.
Right.
Oh,
It's just a lot of work to even find out what you can find out.
Exactly,
because there's so much.
At the forefront. There is so much going
Sure.
on in all directions, whether it be biomedical or pure physics, and everything's becoming interrelated. Where most of what I see is the contributions that are happening is taking something. Settle down over there.
He's taking a piss over there.
Is taking something from one field and applying it to another that people haven't thought of.
Yeah.
So there's a lot of stuff that, physics is going into medicine and vice versa, that it's nothing new, but it's being applied in new ways. And then there's also just things are moving so fast, whether it be nanotechnology or computer processing, that you can have an idea of like, I'm gonna do this, but by the time you get there, it's too late.
Yeah.
I mean, research teams really fight to be first now. And so if you find out there's another team that's doing similar research to you, nobody remembers number two.
Right. So it's a competitive game.
I'm a huge astronomer. I can't name the third and fourth men on the moon. And that's a shame. That's a shortcoming on my half. I've always wanted to commit all of the Apollo astronauts to memory.
You can
but
only
it's
name
just,
the one,
it's just
man.
hard.
Yeah.
No, everyone knows Neil Armstrong and Buzz Aldrin.
Yeah,
but,
that's right. That's right.
Name the third guy.
Yeah, exactly.
It's-
I didn't even think of Buzz Aldrin until
Yeah.
you said it. Yeah.
And
So-
yeah.
Well, I was just curious. So, you get this degree, and so what are your options? What are you gonna do?
So I can decide either to make money,
Right.
which is going into finance. A huge number of physicists get recruited by large corporations to analyze how money is moved around and that kind of stuff, risk assessment. And it's physics is just analyzing a complex system. So
Sure.
if you can do that, they want you to do that for their particular complex system, whether it be a trucking company trying to figure out routes and stuff. There's math that can help with that.
Oh, that sounds awful, though,
so
doesn't
Yeah,
it?
it sounds awful.
Computer
but,
science problems too.
Exactly. Well, and physics and computer science you almost
One and the
can't.
same.
Computer science is becoming paper. I mean, it's like you can't do it without a medium to do it on, and it used to be paper, and now it's like computer science, because the calculations that they're doing you can't physically do on paper.
Oh, right.
It just can't be done.
Take years and years.
Yeah.
He's got a computer science degree.
Yeah.
Yeah.
Yep. Just graduated in May.
Really?
So, yeah. It's been a while.
It's scary to graduate. I'm glad I'm not there yet, because then you
Yeah.
have to actually do something.
So what do you want to do then? So what are some other things besides working for truckers?
Or you can decide to go. You can either stay in academia or go into research.
Yeah.
And not make a huge amount of money,
But do what you like.
Maybe actually make some sizable contributions to the forefront of science.
Right.
That's what I really want.
Yeah. For
Is,
sure,
is
man.
to say, there was this chain of thought from Neanderthal man to the universe becoming conscious, and I made my little contribution right there.
Right.
That they didn't know this before me.
Yeah.
And that's a difficult. That's a lofty
to
goal. but I
find
think-
something out that nobody else knows
Yeah.
is fucking. You don't even think about that. Like
It's extremely difficult.
a
I mean,
discovery
it's-
scientifically. Yeah.
It's really easy to look back with hindsight and say, isn't it obvious that a perfect example is of different mass falling at the same rate. And Aristotle, I believe, fact check me, fake news, he said they didn't. And at the time it was just logic was the mode of science, and that stood for, I think, over 1,000 years before Galileo said, why don't we actually test it? And then the whole idea of the scientific principles becoming not logic-based but experiment-based really started with people like Galileo and around that time period.
Mm-hmm.
And that changes everything, actually testing things. And so for forever it was just assumed that objects that were heavier would fall faster, and then you test and it doesn't happen. And then once you have that and that becomes normalized, you say, well, of course, isn't that obvious? But it's not obvious.
Right.
And none of it, if you really take away your own ego, none of it's obvious.
Yeah.
Uh,
Because, like, you think about it right now, you're like, what else is there to know? And then it's like, well, that's how it's always been until someone finds something out, and then it's like completely, fought against forever, and then we all finally
I
cave
just
in.
read an awesome chapter in a weather book about kind of the history of the layers of the atmosphere. And it was these guys in France setting up balloon. Well, at first they used kites. It was this amazing story. And they would have these mile-long piano wire kites. And these things had to have been huge to hold up miles of piano wire. But they would always break, and then you have this huge wire, falling onto the city and causing problems. And so they banned him from doing that, and then they started figuring out balloons.
What time period is this?
This is, I want to say 1700s.
Okay.
It's back a ways.
Yeah, okay.
And another thing that I thought was really novel is they didn't use parrot. So nowadays, I've had the pleasure of watching a weather balloon through a telescope rise into the upper atmosphere, explode, and then fall back to Earth. It's
really
awesome. If you ever get it, it looked like someone walked up to me and said, "Bet that's not Venus." And I looked at it and I said, I bet it is. And he goes, no, it's not. And so we looked at it, and I mean, it was like right in the general vicinity where Venus was supposed to be. But
and it was a weather balloon?
Super bright. And
how far away?
It had to have been, I mean, I don't know exactly how far up. I mean, they're going miles up.
Yeah.
And so it was probably 10 miles away or so.
Yeah. And it shines bright, huh?
Yes.
Huh.
Well, it's a white balloon. I mean, it's highly reflective. And
Yeah.
It's huge. As it expands into the upper atmosphere, it gets extremely
So this was like
large.
daytime?
Yeah, it was about an hour before sunset.
Yeah.
So, so now when it explodes, a little parachute deploys, and the science gets floats back down to Earth. But at the time, they used another balloon.
Mm-hmm.
So they'd have the main balloon, and then they'd have this smaller balloon
that would take it down.
When this one ruptured, it wasn't so big that it would expand and blow up, but it was big enough that this thing could fall back down and not break.
Right.
And simple things like that completely changed the world. I mean, it was there was a time before we had a concept of space. So the atmosphere just went on forever. And so, I mean, these guys literally wanted to figure out the layers of the atmosphere until you got to the sun.
Yeah, because they had, I mean, why wouldn't they think that?
I mean, that's, the logical conclusion is that it would end at the sun. I mean, you can't go past the theoretical center of the system.
Right.
Which is just, I mean, it's just so interesting to think of a time when you didn't have a concept of space, or what space was.
They just thought that was just the
but
sky,
it's also
right?
completely accurate. I mean, the atmosphere does not have a boundary that, okay, now you're in space.
But
It's
you don't think of
completely
this. You don't
arbitrary.
even think of the sun as in the sky. You know what I mean? Like you think of it as in space.
Yeah, and it's I mean, to most people, it seems obvious that
Sure.
the Earth goes around the sun.
Oh yeah.
and that the Earth is rotating. But those were huge debates for hundreds of years.
But yeah, what was
that
the
Earth rotated.
Leonardo Bruno guy got burned at the stake?
Yeah,
you know?
that was even further back. He
was like the first guy to like suggest like a heliocentric universe,
well,
right?
I believe his thing was that the stars were other suns and that there were other planets.
I think he was also
around.
saying that
yeah,
we go
around.
around.
He probably was.
Yeah.
And that was like,
Fuck you.
no dice.
Yes.
But
and it was like 10 years later, Galileo looks through a telescope
you
and we
had-
find out.
but even that wasn't enough. You had guys that the science at the time said, if you were on this spinning ball, you would be going so fast because they knew roughly how big the Earth was. And so for an orb of that size to be moving at that speed, rotationally, the equator, you're going roughly 1,000 miles an hour. They said,
Right.
well, obviously you're not going 1,000 miles an hour.
It
so
doesn't feel like it,
obviously
yeah.
the Earth is not rotating.
Right.
And it took a lot of subtle experiments, the Coriolis effect.
And like that's like, that's where mathematics comes in and explains it, right? Because we can't comprehend that. Like it doesn't. We can't feel it.
No, math doesn't explain it. Math gives you the language to refute evidence or to put evidence forth. But math on its own doesn't give you much. I mean, and math is usually ahead of physics. So there is probably math right now that we have no idea that it has a usefulness in the real world.
Okay.
And it'll probably be 50 years before someone figures out that, oh, hey, this theorem that this guy was working on? You can actually apply that to... And so, like, the forefront right now, I just watched a really cool YouTube video. It's about if you can go to infinity, you could bisect an object into discrete packages, rotate them, and then create more objects. And you can't do that in the real world. You can't take that salt lamp, cut it into 5 pieces, rotate it, and now have 10. But they're finding correlations to the subatomic world where that's kind of what it looks like it's doing.
Right.
And so now you're saying, okay, we observed this. Here's the math that says that.
Right,
Maybe
because so
these
the
are
math is why we know
maybe these
that.
are the same things. It helps point you in a direction.
Yeah.
But there's really, I mean, the thing that blows me away about mathematics and why I get closer and closer to math every day is one of the most famous quotes is, it's just stupendously ridiculous that it works, essentially, paraphrasing. Take geometry, the ratio that gives you pi, just the fact that works and it's a true statement. Another one is, I don't know how far you guys have gone in like physics and mathematics.
He's been far, not me at all.
So, like if you plot velocity, your acceleration is the area under that graph. Physics found out that relationship before math found it out. So like math knew you could do that, but it made no sense that would apply to something in the real world. That you could take, which you can actually take the position vector of an object, derive it into a velocity, and then derive it into an acceleration. Just the fact that operation corresponds to the way objects move, that's so bizarre. Why should it be that objects obey this certain mathematical operation?
Right.
It's just so bizarre that's the world we live in.
Right.
You can have equations that can predict it as well.
Yeah.
Once you derive those.
Yeah, so then you can start saying like, if it does this, then that, or if we, make something that did this, it could do that.
Right.
And I mean that's basically engineering. Is I want it to be this. I know the rules, so I can build something that will be that. And before then, which I mean the ancients were pretty good. But without that, you basically over-engineer things. And so you come up with the pyramids or something, or the Colosseum.
Those are over-engineered?
It's probably over-engineered. I mean,
without mathematics?
They built things to last.
Sure.
They built things for different reasons. But in terms of strength and weight, you no doubt could build a building that's lighter and cheaper than the Colosseum.
Okay,
and that's what you're able to do through knowing the rules before you set out.
Right.
I would venture to guess it would be a lot easier to invent flight after you know the rules that allow you to fly.
Sure.
But everything seems. Humans are also great at pushing the boundaries before you know the rules. So flight and everything came around right as all that stuff was being. I mean, the Wright brothers, basically figured out the airfoil for themselves with a wind tunnel.
Yeah.
And it really wasn't. I mean, the obvious YouTube video of these flying machines before the Wright brothers proved that people did not know the principles behind flight. You've got an umbrella that's just going up and down, and you think that this thing's gonna take off? Like, why would you think that?
Right. So you think they had some prior knowledge to that or something? Or
No, that other people didn't.
Oh, okay.
And the Wright brothers, I mean, they built their own wind tunnel test, and as far as I know, they were kind of one of the first groups that really approached the problem. They approached the problem in a different way than other people had.
Yeah.
They looked at birds really closely. They had that wing warp, which is actually why the Wright brothers weren't able to dominate aviation. There's this huge I don't think a lot of people know about it, of Curtiss and Wright. So they had the Wright brothers, and then you had Curtiss. And Curtiss wanted to dominate the airplane industry right after the Wright brothers, and he wanted to cut a deal with them. They wouldn't do it. One of the Wright brothers was really against it. I can't remember which one. They all sound the same, But Curtiss figured out rigid wings and ailerons, which is what every plane uses now. You will not see a 747 with their wings warp, but they don't warp to control the aircraft. They use ailerons and flaps. And the Wright brothers patented wing warping. So when you had canvas biplanes and all that kind of stuff, I mean, you couldn't build an airplane that used wing warping, and so it was really hard to control an aircraft without that.
Yeah.
Now, did we unplug?
No, we're good.
Just novel things like that.
Right. And you only hear about the Wright brothers.
Yeah.
Why don't we hear about this? Curtiss? It's just one of those things.
Because nobody remembers who was second.
Yeah.
It's only.
Well, it's one of those things. Who was the other guy that was involved with evolution? There was another guy. There was Darwin, and there was another guy.
I'm sure there was.
And they worked together, and without the other guy, it wouldn't have fucking happened.
Probably, yeah.
A lot of the times, though, in those races, the second guy ends up taking over. Just in the case of the internet, AOL search was way before Google, but Google ended up coming in and dominating.
Yeah.
And the same thing with Obviously MySpace.
MySpace was first, yeah.
But Facebook is
the second.
A whole other game. Yeah, they're the second one.
Right.
Yeah, well, no one wants the 1.0. The 2.0 version is better. I mean,
exactly, because they learned from the first guys. Yeah. Yes, exactly. Yeah.
Well, and so one of the Wright brothers died young, and the other Wright brother blamed Curtiss for it, for whatever reason, just because of the stress of him on their company and stuff. He did not like the guy, and so they, hardcore. Well, then after everyone dies, Curtiss and Wright, and now there's a company called Wright Curtiss, that is still huge in airplane manufacturing.
I was about to say, what's this mean? What they do, dude? What they do?
This.
This?
This is different.
Wright and Curtiss.
No, these are two different things.
Let's shake you up a little bit.
I'm just thinking about progress and just how we're on this continuum. And
what the fuck is that?
I don't know.
What did my dad bring down on that plate?
Just a note.
Yeah, what did it say?
Have Jeff stick around. He's going Christmas shopping. Radis.
He's getting you something for Christmas. Yeah.
Sweet. Does he know what I want?
I don't know. Probably.
I want an NASA hoodie.
He's really you want a NASA hoodie. Dude, Walmart, man.
I want mine.
Walmart.
I want mine given to me. That's my whole thing. Is
Oh, okay. You don't want to go get one.
well, I want one from them.
Oh, from NASA.
That's
I see what you're saying.
That's
I
why
see.
I want the job. I just want the swag.
You want to work for NASA?
Oh yeah, you didn't know that?
I don't.
That's the whole,
obviously.
That's the whole plan.
Okay.
Yeah, just to get the hoodie
Just for
and the,
the.
and the badge. You know.
Yeah. Okay.
No, actually, let's see here.
Let's see what you got.
I'm gonna dig into my bag of toys.
Yeah.
I'm just gonna I'm gonna throw some credentials out there just because I'm that guy. If I even have it.
You can plug it in, man.
I don't think I have it. It's my turn to rip the mic over.
You can put this up on the table if you want. I didn't know if you had like a magic set or some shit. Yeah, I never know with you, man.
For my next illusion, right? That's what they say. I got accused of being a magician once. It's like, I'm a juggler.
I could so see you being a magician.
Don't have it. So, I'm a volunteer for NASA.
Mm-hmm.
I don't know if you knew that.
How do you get that?
You do a lot of astronomy outreach, and then you apply to this program that they run, which is called the NASA Solar System Ambassador Program.
We should tell Schluter about that then.
Yeah, really.
Yeah, we got a buddy that wants to
Yeah.
work for NASA. Yeah, and
He's pretty headstrong.
He's
about it.
headstrong.
It's I think it's a nice thing to have on an application. You know that you volunteer
Mhm.
for them. They also help you be a better volunteer.
Yeah.
So they do a lot of science lectures, telecasts, and that kind of stuff. If you need swag for some big event you're doing, I want NASA stickers or something, they'll send them out to you.
Right.
They did a huge thing for the eclipse
Yeah. Yeah.
and that kind of stuff. So
They
I
have a
thought
lot
I
of
had
different.
My badge. I thought I had my badge with me, and so that's like my
It's not
first
on your code, is it?
No.
No.
And
They
so
have
that's
like a
my
bunch of
first-
different positions too with NASA. I mean, you think
yeah.
working for NASA, you think, oh, you're an astronaut or you're one of those guys, talking to the astronauts. But
Yeah,
there's
no,
like
I'm going for broom pusher.
that's
You know, if I can get that gig,
now to get that gig, what do you got to get?
bachelor's of science. That's why I'm getting one.
To fucking push a broom?
No, I'm sure the maintenance department is not subjected to the same.
Yeah, that's what I'm
scrutiny.
saying.
But to apply to any NASA post, you need a
Yeah.
bachelor's of science. That's basically it. And so, I mean, there's guys that worked on the Hubble Space Telescope that were geologists.
Yeah.
It doesn't, your background isn't at, the only astronaut that came from Wayne State graduated from the medical.
There was an astronaut that came out of OCC?
Yeah.
Yeah, I heard about
that.
Yeah.
It's like, man, everywhere I go, I'm
Did you
not,
go
I'm
to
not the
space?
first. If I get
Yeah,
there,
he went to space. He's on the
Yeah.
space station.
From OCC.
Graduated from
yeah.
OCC.
I'm sure
Holy
he
shit.
went on to other things. They didn't just
No,
say,
dude, he was
"Oh,
out
you
the door of
you got an-
OCC.
You got an associate's degree?
Dude, he only took the astronomy course,
Yeah,
and he
exactly.
did so good on the test.
So
They
good.
put him in space. Did you take that class? Probably not at OCC.
I took an astronomy class at OCC.
There's only the one, right?
I have no idea.
Yeah, there's only the one. I took it. Did you have like Martin, that old fucker?
You're talking about something
You've
that's
taken
so long ago.
It is, yeah. How long ago?
I mean, that would have been like
was 3 years.
2005.
It was 3 years ago that I saw you at OCC.
Yeah, but that's not when I took the astronomy course.
Oh, okay.
I took the astronomy course.
It was
the
Martin
first
though.
time I
He's
was
been
at
there.
OCC.
He's been there for
Yeah.
like my buddy's dad had him.
Okay.
So yeah,
then I probably
you
have.
probably did.
I remember not particularly caring for that class.
No, I thought he was awful. He was very religious,
Oh.
and it was a climate change
See,
denier.
I'd
like
like it
all
now
this
because
shit.
I'm just like, I
Dude,
go toe to toe with
he
them.
was like, he called Al Gore an idiot in our class,
Oh, boy.
and I'm like,
Yeah, that's rough.
I was just like, what? I was so disappointed too because it was my first fucking
Yeah.
year in college. I was all excited to take this, and this
See,
guy's
and
a
I have-
dummy.
I have there's a great astronomy and a physics teacher at Wayne State. He gives out cha-chingings. And
He gives out what?
If you get like a problem right, he'll be like, oh, cha-ching. Which just makes people laugh because it's like,
The fuck was
how
that?
much am I paying to be here for?
Right.
But and like every problem we would do on the board, he'd be doing the problem. Oh, this is pretty sweet. Look at this. and everyone's like, this isn't sweet, but some of it is.
This sucks, dude.
Well, I just got through E&M, electromagnetism.
Okay.
And not my favorite course.
No.
I'm definitely not being an electrical engineer, I'll tell you that much.
Yeah.
It's not intuitive stuff. You really got to put the time in. I mean, I did fine in the course, but like
You're really headstrong
I
too
wasn't,
about it
I
too.
wasn't like, oh man.
You were
I mean,
right.
definitely at points in the course when you like learn things about how circuits operate, you just go, wow, like this is how, our whole modern world is electromagnetic. And it's something we didn't even know
Right.
really existed 100 years ago. And,
Yeah.
and so the story is very well documented
Yeah.
of us figuring out, if you induced a current through a loop and then I could make this thing turn, and now you've got electric motors, electric generators. And
Who was that one guy that like?
Tesla? Is
No, not Tesla. No, I know fucking Tesla. He was the first one to invent the electric motor. Very first.
I thought Tesla was.
No. No.
It's
Musk.
probably Faraday.
Elon Musk. No, he's way older, man. Like starts with like an F, I think, right? Faraday. Michael Faraday.
That would be my guess.
I think he was the first to come up with an
People are
electric.
gonna know I didn't do good in the course.
Yeah, I think it was
He doesn't know it's
Faraday.
Faraday? That's like problem number 17.
The fucking kid who's in algebra 2 knows it.
Well, and that's the other thing is I enjoy the history, but I'm not huge into the history. I like the science.
You're pure science,
Yeah.
man. You really are.
Yeah, it's like, oh, some bag of meat figured this out. Big deal. We're all the same
bags of
bag of
meat.
meat.
We're all fucking bags of meat, man.
Like if it.
Some of us got holes.
I mean, if it wasn't Einstein, would it have been someone
The ones
else?
with holes don't usually figure anything out. I'm just kidding.
It's the same number of holes. I don't know what he's talking about.
It's true.
I'm sorry, go ahead.
I don't know where I was at.
history.
I started getting like this vitamin water started looking
Yeah,
better.
go ahead,
I
man.
gotta say.
What I find is amazing is all of the electrical engineering and stuff like that. You can get a bachelor's of science with that, but then yet I'm doing all of my software engineering on top of that, and yet I know nothing about that.
Yeah.
I don't know anything. And just how I can get a bachelor of science on something that's dependent on another thing.
Right.
We're getting
But you know nothing.
farther and
Yeah.
farther into this loop that if something breaks, I'm totally screwed.
Yeah.
I can't even use anything I learned. I can use like the abstract way of organizing things,
Mm-hmm.
but other than that, there's like absolutely nothing.
So, in my day-to-day life, I do CAD work for a civil engineering firm.
You do what?
CAD work, computer-aided design. Is that
Okay.
what the kids are calling it?
Yeah, you'll have to
So,
bring
and
it down.
there's a common problem in hiring that we see where people either know the job
Yeah.
and don't know AutoCAD,
Mm-hmm.
or they know AutoCAD and they don't know the job. And
Okay.
it's way easier to know the job and teach them AutoCAD because it's a few commands that you really need,
Yeah.
and then a bunch of stuff that you never need. And it's a similar thing where you can know this program but know none of the underlying principles of the job you're trying to do. And
I feel like that's a lot of
it
kids
really
right now.
does
Dude,
not
that's
in
me.
school.
That's me in math. Period. That was the problem with math. Like, I'm so far behind both of you. It's just not even funny. It's like the difference between running and fucking
Yeah.
crawling. But like when I was like taking math classes, it was just rules, and I didn't understand why, and that
Yeah.
pissed me off.
I just had a really long, drawn-out debate with a buddy of mine about math, and he is about as blue-collar as it gets. No mathematical experience. And so we're like on two different planes trying to talk to each other. Planes are... No, I'm sorry.
Fuck.
And,
2D space?
and I
3D
could
space?
not bridge the gap. And I sat there for like the next day pondering like, how could I have reached him better? How could I?
That's a
explain
good thing to
this
do. Yeah.
better?
Yes.
Because teaching is like my backup plan. Like when they tell me you're not going up to space, have you seen your
Is that what
Facebook page? You're not going to space. Then I'm like, okay, I'll teach. But math is a language.
Sure. Yeah.
It's dependent on the notation that you use, there's all kinds of different systems when you, and I'm like just getting there really, like calculus and linear and all of this stuff is really just like the background to getting to the really bizarre
Actually
stuff.
applying your
Not
math
even
skills.
not even applying, but getting into the really heady stuff that's like whoa, like when you start saying, what if we changed, once you know math at a fundamental level pretty well, you can start changing the rules and saying what happens.
And that's what a physicist really does, right?
No.
No?
That's mathematician. A mathematician will
Okay,
say,
a mathematician,
what
yeah.
happens if so like addition, subtraction, those are all operators. And to me, like, and I'm pretty sure it's correct, like derivatives, integrals, these are operators.
Yeah.
Some of them are and they follow certain rules. So like addition and subtraction has the commutative rule where you can change the order that they're in and it doesn't change the outcome. 4 minus 3 I'm backwards. 4 minus 3 is not the same thing as 3 minus 4.
Sure.
But 4
4 plus-
times 3 is the same as 3 times.
Same with addition too.
And same with addition.
Yeah.
So there's rules and constraints to these operators. And so you can start to say, well, what happens if we change those rules? What happens? And a lot of what mathematicians are doing is playing around with that kind of stuff.
Mm-hmm.
I mean, nobody's doing this, but just like to make the example where you say, what if I say a negative times a negative isn't a positive? What if I say it's a negative?
Right.
I can do that.
Right,
with
because
math.
right.
And one of the things in math I'm most afraid of is proof math, because it's really
You have to compensate for every single variable that you can throw at it.
well, proving something is different than solving an equation. Proving something is saying -1 times -1 is 1, and here is my proof of it. Is taking there's proof by contradiction. There's all these different category. We've made categories of how you prove things.
Yeah.
Ramanujan, there's a movie, The Man Who Saw Past Infinity, or something like that. He was a mathematical genius. He was just he came from India. He could see numbers almost unlike anyone at his time.
Mm-hmm.
And he wrote these books, and he sent them to someone in London, and they said, this guy's a genius. We need to get him out here. And then he died tragically young from a disease or whatever. Watch the movie.
Yeah.
You can see I'm not a screenwriter. But he has in his book, something, this is the smallest number that's the, composite of these other two cubes or whatever. And then he says, interesting proof in the corner, in the margin of his notes. And no one had, since then, this was like in the 1920s, 30s or something like that, maybe 40s.
Been able to find that.
Nobody's been able to prove that.
Yeah. And
It's
he did in his head.
It's unlikely that he was lying about the proof.
Yeah, why would he do that?
Yeah.
I'm just going to write this fuck with him a little bit. Just in case I die.
But nobody's been able to figure out what that proof is.
Yeah.
And he just happened to not write it down. And so it's like there are things out there that have solutions that, there are well-known, you can go on Google and say, the top 10 mathematical mysteries. And there are things that they are trying to prove right now that if you prove one of them, you'll get like the highest honor in math. It's some, I don't know what award it is, but
Really?
You can get like $1 million too,
Yeah.
for solving certain problems.
I mean, these
Really?
are problems that,
Wow.
theoretically can take years.
Right.
And people work on, that's what mathematicians kind of do, is they find interesting little problems. Mathematicians are solutions looking for problems, and so they find little problems, and then they just they'll just work on them in the corner, or if they're,
While they're teaching or
if they're
something.
a serious mathematician and they're getting paid to do research and stuff, then they're going to be working on things nonstop. But most of the mathematicians I know have a million pet projects.
Yeah.
That it's just, because I'm curious about this, and so I've been kind of fiddling with that,
That's
when
just
I
like
have
their
time
hobby,
and
you know?
stuff in it. Yeah.
Their mind just
And-
works in a different
And
way.
it's really neat when you can know enough to know what the hell they're talking about.
Yeah. Are you at that point?
No, not
No.
really.
No.
I won't say that I am. I mean, I just got through calculus. I'm literally on the ladder of mathematics. I'm on the second rung.
Mm-hmm.
When you get through algebra and geometry is really understanding the framework. And then to me, calculus is figuring out what you can really do with that framework, and then it just gets crazier from there.
Okay, so this is off topic.
But hold on.
Okay.
But calculus, and I could be wrong about this, but like when I give you the equation for a circle, and I say the area of a circle is pi r squared. Okay, where the hell did you get that from?
Right.
Calculus allows you to figure out what that equation should be. And so this argument that I have with my buddy, he just doesn't understand the symbology of math. Why are they using these symbols? Why don't they just say what it is? And it's like, well, if you had to explain what division is every time you wanted to divide something rather than just having a neat little symbol for it, math would be grueling.
Yeah.
And division's an easy operator. There's very complex operators that have much more subtle rules to them, and so you'd have to explain that every time. And so you can, when you put a letter, Greek, Arabic, whatever it is, a B, I'm going to call the radius R. Instead of saying this radius is 4. When you call the radius R and you start working some of these things out, you can see that the radius is one of the determining factors in the area.
Uh-huh.
If you just measure areas, and actually use calculus, but you say, I'm going to do this with a radius 2 circle every time, I might be able to find a correlation as the radius. If I keep doing iterations of different radii, I could find some correlation. But if I just leave it as r and I work it down, I get pi r squared. And then now I know that the area of a circle is dependent on r squared, pi r squared. And you can do that with all different shapes and figure out what is the determining factor going on here. And then when you get to complex shapes that are things that are happening in the real world, the vector patterns of wind and stuff like that, and you apply those same principles, you can figure out what's actually going on.
Okay.
And that's, to me, beautiful.
Yeah.
But
It's
it's
confusing
hard.
to me.
It's hard. No.
Yeah,
it's,
for
it's, It's subtle. It's not easy, and a lot of people's intuition tells them, if they're doing a problem on a test and it says you've got a circle of radius 2. All right, put that in there right now. And sometimes putting things in right away makes the computation much worse.
Mm-hmm.
If you just wait till you get to the end, you get something that's 3/4 pi r squared, and you just put the r in there, and then it's a really easy computation. Okay, ask your off-topic
Okay,
question.
well, first, I'm going to go take a piss real quick.
You should correlate it with
I gotta
other
piss
noise
really
that's
bad.
coming.
Cool.
Oh, shit.
Well, you know how we're talking about that boundary gap from like electrical engineering to computer science? That maybe there is like a simpler way to explain how I could be able to learn the electrical engineering and also the computer science stuff, because I'm sure a lot of it is the same, but maybe we just have all of this garbage in there in between that makes it so hard to understand that gap. But that kind of goes back to the operators too.
Yeah. Well, and I mean, they're still discrete disciplines. So I'm not a computer science guy. I want to get into coding, and I'm figuring out, what I don't know and how I should go about learning it, but I haven't actually started any of it.
Yeah.
But so coding, as I understand it, it's a mindset. It's how if your brain thinks the right way and you can think logically and you can create these sequences of steps, you can code. But you can apply that coding to anything you want. And so if you don't know physics, you're gonna have a really hard time coding a program to emulate physics.
Sure.
And if you don't know sailing, you're going to have a hard time coding something that's going to emulate a ship sailing. Whatever you're trying to accomplish, you're going to have to know quite a bit about the rules and which usually comes back to math and physics, because whatever you're trying to represent with a computer, when I was in, I don't know if it was Algebra 2, matrices, the little things.
Linear algebra.
That blew my mind what you could do with that, and that is all what Photoshop is matrices.
Yeah.
So all of video editing is matrices, and our computers can do things to matrices through clever algorithms that you could never do by hand.
Yeah.
And
It's almost like a Sudoku puzzle that the computer can just solve.
Yeah, I remember
right away.
I think I inversed a 3x or a 4x4 matrice in one of my algebra classes before the teacher got there, and he came in and he was like, because I filled, because it's just so much work. It's just busy work. It's not difficult. It's just a lot of computation.
Okay.
A lot of multiplication
Yeah.
and addition, and so I just went across the board doing this, and he was like, "Man,
Get a
okay,"
calculator.
like.
You don't want to use a calculator.
Well, no. Who wants that? I actually, I'm trying to get rid of my calculator as much as possible. I found a slide rule in my basement, so now I've learned how to use a slide rule.
What's the slide rule?
Oh, where's my backpack?
I can grab it for you.
Grab it.
It's like, it's either in the main pocket or the one just in front of the main pocket. It's not going to be there. No, it's not. It's bigger than that.
Is it?
Oh yeah. No, not that one. It's going to be a leather tube.
Oh.
No, check that main pocket. The one in the back.
There's your zipper.
Yep, right there.
There it is.
All right,
All
this
right.
is
Looks like a knife holder. Or
this is
something.
a
It's his weapon.
fantastic little invention that, like, we flew to the moon using these. Like, they didn't have in the late 60s. They didn't have personal pocket calculators. This was your calculator.
Yeah.
And so how this works is there's a bunch of logarithmic scales on here that you can do multiplication. I can do trig functions. I can cube something. I can cube root something. I can square something. And believe it or
You
not,
use that for trig?
God damn.
yeah.
Wow.
There's ones that have even more fun. This is like baby's first slide rule. It has like directions on the back, but
Nice.
I have another one that has like double the amount of scales that one has.
Does that just mean it's a lot longer?
No, it's the back has scales and the front.
Okay, and they
And
correlate
they're
to
all,
each other.
yeah, they're all different scales that do different functions.
Wow.
And
That's Greek to me, man.
so, but, all right, so you can get a calculator in there. Give me a 2-digit number, and we'll multiply it by another 2-digit number.
Mm-hmm.
And I'll do it on the slide.
A 2-digit number.
Two digit by a 2-digit.
All right.
That's pretty hard to.
Like 47
yeah.
multiplied by 68.
68. 47
Times 68.
No peeking.
That's 8. By 68.
Yeah.
Yes.
I'm gonna say that's 320.
3,000.
Oh, see, you gotta know where your decimal place goes.
Yeah.
So
It's close, though.
yeah,
It was
so
3,196.
I mean, I'm gonna call that a win. Really, but you have so the thing that the slide rule can't do for you is
Right.
place your decimal point.
Right,
So
right.
you have to intuitively know. Okay, if I'm multiplying 27 by 5, that's gonna be in the hundreds.
Right.
So whatever I get here. So I'm not great at that, but I mean, back in the 60s when you really had to know this,
Yeah.
I mean, I would have been able to rifle that off way faster than you trying to do long
it.
division or long multiply
Yeah.
with
on
pen and paper.
Right.
And then I can easily take that number. So say I do some calculation with this, I can then just go right up to another scale and square it.
Oh, okay.
And I mean, so you can do pretty crazy things with this really simple tool. And so for like the goofy calculations and stuff or experiments that I try to do is like recreate ancient experiments. This is perfect for me. Like no calculators allowed, you know.
I didn't see that. That thing slides out here too at the end.
Yeah, so there's
Wow.
a bunch of different. So you have like the C. This is the D scale. This is the C scale. The S is for sine. The T is for tangent. And it's just knowing what scales you're supposed to use and how you incorporate those together.
That's cool,
And
man.
it's really novel. But it's
Is that people still use those? No.
They've been completely overthrown by the
Calculator.
A pocket
Graphing
calculator can
calculator.
do way more than this can.
Yeah.
I mean, my
You're old
my
school.
calculator can do definite integrals.
Right.
That ain't gonna do definite integral.
Yeah.
All right. So my question was, see if you can explain like Lawrence Krauss.
One of my favorites.
Yeah, he was talking about infinity
Yeah.
and that there is some larger infinities than other infinities.
Yeah,
What?
there's larger infinities, and it's because. So when people
just can't
say,
wrap my head around that,
because
yeah.
when people say infinity, you think of a number, and infinity is not a number.
Right. No, I think of just I don't know how to even
Because a lot
describe
of
it
people
without
say
saying infinity.
they say there's an infinite amount of X possible. There's an infinite possibility of musical computations that people could make, or there's an infinite amount of this or that, and infinites aren't really. They're not an amount. Infinities don't work the way normal operators work. So when I say 1 + 1 is 2, 2 + 1 is 3, infinity plus infinity is not two infinities. It just stayed where it was. And so when you apply operators to infinites, they don't behave in predictable ways. One of the best examples that I will not be able to explain to you if you want the explanation, and it's not a great one, or it's not a very satisfying one. You can go on Mathology on YouTube. But if I add up all of the integers, so if I add 1 + 2 + 3 + 4 to infinity, the answer is -1/12.
What?
Makes no sense at all. But you can prove it through comparing it to other infinite series.
If you add up all the positive
If you add
numbers,
up all the integers,
they're all positive numbers.
they're all positive numbers.
And it's going to give you
And
negative.
it gives you -1/12 as the solution. Infinites they're not intuitive. So have you heard of Hilbert's Hotel?
Mm-mm.
Okay.
No.
So it's I'm gonna try to say it right. It's the Grand Infinite Hotel or something like that, and it's an infinitely large hotel with infinite number of rooms, and they're all booked up.
Yeah.
And then he comes along and wants a room. Well, rather than turning him away and saying we're all booked up, the hotel manager cleverly says, if I move the person in room 1 to room 2, the person in room 2 to room 3, the person in room 3 to room 4, on to infinity, now he can go in room number 1. So now I've made a spot in an infinitely booked hotel. How did I add a region to this infinite space?
When infinite's not a number.
Well, it's because it's infinite that adding something to it doesn't mean anything. So if a infinitely large bus of people come to the hotel and say, we want a room,
Same thing.
he can move the person from room 1 to room 3, the person from room 2 to room 4, and basically stagger. And so now there's an open spot every other. And so now he can fit an infinite number of people into the hotel. And it works both ways. It's, dividing infinite by 2 is still infinite.
Yeah.
And so to actual answer your actual question rather than just droning on about infinites, there's countable infinites and there's uncountable infinites.
Okay.
So if you count off all the integers, 1, 2, 3, 4, 5, 6, 7, that's a countable infinite. But there's an uncountable infinite in between the integers, which is the real numbers. So if you tried to count the numbers between 0 and 1, where would you even start?
0.
Okay, but now
That's what I would say.
so what's the next number?
Oh, right. Yeah,
You
there's an
can't.
infinite amount.
There's
Point
an
zero zero
infinite
zero infinite.
onto
Yeah.
and so because of that fact, it's the simplest way I can
Sure.
think to explain it. There are more numbers in between 1 and 2, or in between 2 and 3, than there are in the countable number line. And there's really interesting. You can watch videos that demonstrate the proofs of that. They're a little convoluted, and you really have to watch them a few times to go, okay, I'm starting to believe this.
Yeah.
But then you get to something like all the integers add up to -1/12, and you're like,
Fuck you.
what am I supposed to do with this? But it's aside from the universe itself, we don't think there's any infinites in reality. That you can't.
Do we even know for sure that the universe is infinite?
No, absolutely not.
Right.
But
We think it's pretty probable.
But there's no evidence for or against it.
Right.
And so it's hard. It's really hard to say. And there's interesting side effects of an infinite universe. That's when you say, there's another room that everything that's happening here is happening.
That's
in
like the
another
multiverse
room.
theory. Yeah.
There's also
Yeah,
different definitions of a multiverse and how you.
Sure.
I think Max Tegmark, the Swedish guy, classified universes. So there's now like 4 different types of which universe used to mean everything, and now it's like, he was really defining parallel universes. So there's the universe beyond which what we can see.
Yeah.
He calls that a type of parallel universe, even though it's still a part of our physical reality. It's just the place that we can't get to.
Right.
And then there's actual, multiverse brain theories and all that. And then so there's different, and then there's the sum over the worlds or whatever, where every possible quantum fluctuation causes another parallel universe to butt off. So every possibility.
I've heard that before, yeah.
So now you have like these Russian dolls of universes within other parallel universes, and it's just this very odd tree like.
Oh my god. Yeah, I don't know.
Well, the other thing is,
that's all I gotta say.
okay, that's great. What do you do with it?
Exactly.
What do you do with that knowledge? And at the forefront of physics, this is the whole thing of saying, what if I say -1 and -1 is -1? So these physicists are saying, okay, what if I say mathematically or it actually happens that there are these parallel universes, and now I apply what I observe to this model, and you get something out. And that's kind of like where string theory is right now. It's like we have no reason to believe this is true. We're just saying, what if I say that fundamental particles are not point-like structures, they are these tiny vibrating strings, and then I apply that to our mathematical models, and it's
it seems to me like
giving
all this
certain things out.
It seems to me that it's like it's impossible for a human to actually wrap their head around these things. I mean, is it just like even the most brilliant mathematicians and physicists, do they really understand what they're finding out?
There's a famous quote by Richard Feynman, who's one of my favorite physicists of all time. It says, if anyone tells you they understand what's going on in quantum mechanics, they're lying to you.
That's
because it's so counterintuitive and bizarre that you're lying to yourself if you think you understand it. Because to say you understand it says that not only do you think it's right, you think it's completely right, and we know it's not completely right. There's still so much that we can't explain.
Yeah, I heard one time, and I've heard many times, but that quantum mechanics, quantum physics, and relativity don't.
So throughout
Sad.
history, I'm doing this again.
Oh no.
So throughout
Quantum
history,
mechanics and
history,
relativity
there's
now.
been these titans at odds with each other.
Uh-huh.
One of the really famous ones was between Darwin and Lord Kelvin, the Kelvin scale of temperature, over the age of the Earth. And there was evidence for the age of the sun. Darwin was saying the Earth had to be billions of years old for all of this geology to
And
have
what was
happened.
Kelvin saying?
Kelvin was assuming that the sun was made of something that you could find on Earth, basically that it was like coal. And if the sun was made of coal, it could only possibly burn for like 50,000 years. So
Right.
he said, no, the Earth has to be less than 50,000 years old because the sun
Right.
wouldn't be here.
Oh, I see what you're
And
saying.
I'm using concrete physics to prove this. And Darwin said, that's fine and dandy, but look at what the geologic record is telling you. We're
That's
finding
physical
this.
evidence,
We're finding
yeah.
the same plants on different continents, and these layers of deposition. Any way we try to estimate how old it is, because they didn't have radiocarbon dating,
Right.
is
How did they date it then?
grossly. Well, it's called stratigraphication. You make some assumptions on the rate of deposition, and then you infer upon that
Okay.
how far. So it's not supremely accurate, but it's actually still the main way that they determine the age. Because so certain radiocarbon dating gives you good numbers for certain time periods. So like radiocarbon dating, it has to be in something that was living, like wood. And so that can give you good estimates of certain things. Well, you go to some igneous rock that was deposited, 100 million years ago, there's no living entity, and so you have to use other types of radioactive dating, and they're all good at certain things, and it's you got to be a geologist,
Yeah.
but it's more complicated than that. And so really looking at the layers can give you a better sense of different things and when certain things were happening in the environments that they had to have been in. And the fossil records is great at this. I mean, if you find tropical corals on the top of a mountain, in the Arctic, well, it's safe to say that it was not in the Arctic at the time that those layers were deposited. And so just and so they had things like that where they were finding things in the Alps and stuff and saying, how long must it have taken to migrate these things from tropical regions to temperate regions and that kind of stuff. And so it was much older than what Kelvin was saying. And Kelvin also, bless his heart, he also said, like, man would never fly, and even if he could, there's no practical reason to, and this and that. And he was wrong about a lot of things. He was also brilliant in other areas, but he was definitely wrong.
He was around the same time as Darwin then.
Yeah. So this was, if you look up the Great Debate, this is the one that comes up.
They debated face to face about it?
Yes.
Okay.
It's not Hillary and whatever you want to call them.
Yeah.
It's Darwin and Kelvin. That is the Great Debate.
Yeah.
He was wrong. There was no concept of nuclear physics back then.
Right.
So, and then the next great debate was over the static universe, whether the universe was eternal and didn't move, or whether it was changing. And now
Who was that with? Anyone we would know?
Yes, but anyone I can recall their particular name. I know he was a bag of meat. But what did they call that bag of meat?
He had a
Doesn't
name.
matter, does it?
No, it doesn't.
Well, obviously one of them was wrong.
Right.
And it's just kind of funny, the guys that they're brilliant, but for whatever reason they can't let go of their own assumption when the evidence is telling them no.
And that's the ego. That's the
ego.
That's the human part of them.
You will be a great scientist if you can admit to yourself when your idea is wrong.
Yeah.
When you can say, I thought the universe behaved like this. and it doesn't.
Yeah.
You won't go down in history as saying something stupid.
Yeah.
So now the great debate is special relativity, Einstein, and quantum mechanics. Quantum mechanics is the best theory we've ever come up with. It is the most accurate interpretation of reality. We've basically gotten physics down to like the 12th decimal point. Okay, so the gray area we're talking about here is extremely small. Like, this is not, I know we said that, like, objects of the same mass fall at the same speed, but it turns out, like, that is not, whenever the dust clears and we figure out who's right, which is probably going to be both are wrong in some subtle, small way,
Okay.
It is not going to overthrow all of physics.
Right.
Newtonian mechanics got us to the moon. I believe Newtonian physics can get you to Mars. You don't have to compensate for general relativity.
We got to talk about that. Mars.
You can do it with simple Newtonian physics. Einstein's general relativity that changed gravity changed it in a very subtle way right at the margin. I don't know what decimal place, but say at this 5th decimal place. So if you're trying to get accuracies down at that level, like if you're shooting something off to Pluto, by the time it gets there, the 5th decimal place is important. You know what I mean?
Yeah.
Because
Not
any
really.
okay. So say you throw a football, right?
Okay.
But you can only throw it to an accuracy of the 5th decimal place, right?
Okay.
So I can throw it exactly straight, but with an error of 0.0004. On a football field, you're never going to notice that. You're going to be the best quarterback in history. You're always going to hit your target. But if you try to throw that football to Mars,
You're
that
gonna miss.
0.0004,
Because of the distance.
that small amount of error now has become huge.
Okay, yeah, totally.
So, but you have to do something big for that error to matter.
Right.
And so when we're talking about quantum mechanics being good to like the 12th or 13th decimal point, I mean, you have to be in a very particular place for that to be important. And basically where that is inside a black hole.
Okay.
That's where there's a couple of places, but that's basically where it breaks down. It breaks down at super high temperatures or super small spaces.
Okay.
So if so there's a thing called the Planck length. That's the smallest unit of length we think that exists, and it's based on, so as you have higher energy radiation, it has a smaller wavelength, but as it approaches a certain amount, it can't, the Planck length is determined by, oh boy, I have to figure out, this is a chicken and egg kind of thing. So Planck figured out all this stuff, and now anytime we think that there's a limit, we call it a Planck limit. So there's a Planck length, which is the smallest length, and it's like 10 to the negative 20th smaller than a proton.
Ooh, wow.
So it's extremely small. This is the string theories, vibrating strings. They are theorized to be at the Planck length. They are Planck length objects.
Okay.
And you need a particle accelerator the size of the universe to get down to that length. You just can't do it. It's it's beyond our realm of touch. There's a Planck time, which is the smallest unit of time. And then now they're theorizing about upper Planck temperatures. So I think is it called the Planck heat or something? So there's parameters to the universe that we're finding the limits of.
Okay.
And the other thing about like quantum mechanics, and so the big thing with quantum mechanics and general relativity is it's the difference between quantized 1, 2, 3, and continuum, a spectrum where there is no discrete points.
Like a wave, kind of, in a way?
No, so say I have this tablecloth here, and I can cut it in half, and then I can cut it in half, and I can cut it in half, and imagine I can cut it in half infinitely. That is a continuum. But if I say, no, this is made up of discrete entities, so there's a point where you can't cut it in half anymore. You've reached the fundamental building block of this object.
Yeah.
That is quantized. So in the 1920s, or when electromagnetism was really starting to get understood, they figured out that electromagnetism and energy, in a sense, is quantum. It's quantized. There's a discrete unit of charge, the electron, and that charge is this value. And charge can only be broken up into discrete units of that charge. It's a completely arbitrary random number, but that's a fundamental fact of the universe. If I measure the electric charge going through this microphone, it will be guaranteed in units of charge. That it's called a coulomb.
Right.
So, and you can't cut it in half. You can't cut an electric charge in half and now have half of a charge. But Einstein's whole theory works on the fact that space is a continuum, that it does not have a fundamental limit to how you can cut it. And if you, like the whole thing with changing the operators, if you do Einstein's equations and say, but let's make it quantized, it breaks. It doesn't work. It doesn't give you the answers you're supposed to get anymore. And if you do the other to quantum mechanics and say, what if things aren't quantized, they're a continuum, it doesn't work. And so we're at a loss where we say, well, what do you do?
Right.
There's some way that you have to make these things get along, and it eludes the greatest minds of our time.
Right.
I mean, it's going to be really subtle, and it's probably going to be on the order of what Einstein did, where he completely changed our concept of reality. It's really hard today to not think that gravity would affect light. Like, when I think about it, I'm like, why didn't they think that gravity would bend light? It bends everything else. Why wouldn't it bend light?
Right.
But at the time, that was just no. It was a non-starter. And Einstein took the results of the day and said, let's assume these are correct instead of assuming that they're wrong. And what is the consequence of that being true? And what the outcome to him is that everything bent around the speed of light. That the speed of light is constant, so space and time are going to warp themselves to fit that constraint. And it's changed the world. And so whatever the solution to this problem is probably something that's going to be like that, where it's going to change our concept of reality.
Okay.
The universe will look fundamentally. It wouldn't surprise me in 100 years they'll say, you guys thought that space-time was this thing and there were particles going around. That's so goofy. Yeah. Why would you think that?
Of course that's going to happen. Yeah, that's how history looks right now.
And so Brian Greene's another one of my favorite physicists. He's great. And so he has this quote about the aliens come down and they say, show us what you got. Show us what you got. And we come out with all this mathematics and they go, math? You're still doing math? No, you can't do it with math, guys. It's interpretive dance. That's how you understand the universe. Math it's also a problem of being inside the system, where we're in and of the universe, and so trying to understand the thing that you're of and in is rather a challenging problem. And I mean, that's why it took us so long to figure out that the Earth was a sphere and that the Earth went around. Because you're inside it. If you were outside the solar system,
you're part of it. Yeah.
It would be obvious that the Earth was going around the sun. And so being inside the universe makes it really hard to figure out what the universe is from the outside. Okay. And
well, that brings me to a great turning point then, because so we're part of the universe. why do we need to go to Mars?
We don't need to go to Mars.
You don't think so?
Well,
I don't either. I thought you were all for it.
No, we don't need to go.
Right.
We don't really need to do a lot of things
Okay.
that we do.
Okay.
There's no imperative. There's no like, oh my God, if we don't get to Mars by 2030,
Well, like, there's just so many. The environment right now on Earth is obviously going in some negative directions.
There's
a lot of people who are thinking, oh, we're going to Mars.
Yeah,
man,
we're not,
fucking fine.
If you think that Mars is going to save you from global warming, it is not happening fast enough.
Right.
You are not, if you want to go to Mars to get away from the perils of Earth, you're going into an environment that is much worse than the Earth is for you. I mean, you're talking about going to a place that is much more inhospitable than Antarctica.
Right.
So if you're like here in Michigan going, you know what? I can't deal with these.
I'm going to fucking Mars, bro.
I'm going to Mars. It's so much worse. You're gonna have to live underground. You have a very thin atmosphere, cold temperatures, radiation.
Right.
You always have to have a space. They're not terraforming Mars anytime soon.
Well, terraforming takes fucking forever.
We don't even have, I don't think, have accurate estimates as to how long it would take.
Yeah.
I mean, the estimates are all over the place. They're from, we could probably do this in 200 years, or we could do this in 10,000.
Yeah.
And it depends on what you're trying to do.
Don't you think it's kind of a distraction, though, in a way, to like the problems here on Earth?
A distraction.
Yeah.
Well, I think football is a distraction.
Oh, me too, man. Me too.
you
Absolutely.
if you just want to keep people complacent, give them something to watch where they can root for their local team and just forget all of the things that are actually important to them.
Yeah.
I don't think Mars is doing that for most people.
Well, I just think it's like we have some really smart people working on this.
Yeah.
And those really smart people
you think they could
should
be better
should be
served?
doing something better. Yes.
I don't think there's that many people that are really working on
No.
it. Like to the effect of, I don't think you could say, man, if they weren't working on this Mars so much, we'd cure cancer already. Like it's
Right.
It's different fields. It's not a gross volume of people that are wasting their time on Mars. It's a small subset, and then like everything they're doing has benefits to us on the ground. So all the studies that are being done to get us to Mars can be used because they're doing studies of isolation of people. Well, that has real world implications for human psychology. Mm-hmm. And they're doing material science studies that whatever they come up with that they're needing for Mars missions is going to be hugely beneficial down on the ground. I mean,
and that's been like that forever with the space program too.
I mean, I'm writing an article for a local, or not local, some online magazine that's just getting going, and it's why wasting money in space is a good idea. And every time NASA gets a toy, someone puts a sticker value on it, and then people see the value and go, oh my God, $2.5 billion on a robot to Mars? What a waste. These guys, they're milking it, And the truth of it is $2.5 billion for Curiosity is a drop in the bucket. Americans, I think
let's look at some other things.
This is not a made-up fact, okay? Because I know that 60% of facts are made up on the spot, or statistics are made up on the spot. But I think it was 2015, $14 billion in America for Valentine's Day.
I remember you saying that already. Yeah, I remember you telling me that. Yeah,
it's a number that just outrages me. Might not be 15, maybe it's 60. It's in that vicinity. You can have you can have a Curiosity mission. If everyone would just send NASA a Hallmark card once a year,
NASA Day,
we could have all of the missions we could ever want.
Yeah,
we could send.
It's the same thing with like them trying to cut like PBS,
Yeah.
And then like someone compared it to Donald Trump's like week.
Oh yeah.
how much he spends a week.
There's so much money floating around out there.
Yeah.
I
agree with that.
I'm not necessarily opposed to military spending. I think we go a little bit overboard.
But we also bring a lot of things.
We do
yeah,
amazing things.
That's another thing.
It's like where the internet came from.
Yeah.
Yeah. A lot of great ideas.
Yes.
So, but the money's there. It's not a problem of money. It's the money,
value system
the
problem.
money thing gets brought up when people just don't want it, and so they use money as an excuse.
Right.
But nobody says like, hey man, how about like one less aircraft carrier? Just one less aircraft carrier is pretty much like NASA's yearly budget, and most of what NASA does is looking at the Earth.
Yeah.
Most of it goes to the satellites that are looking at ocean salinity and temperature and the dust flow off of the Horn of Africa. It's Earth science. Earth science is what most of NASA's budget is for.
Right. And that's what I was saying. It was like, we're all part of the universe. Like, we don't have to go out there necessarily to be in the universe. We are in the universe right now.
We're already there. We're already in space. There's a famous quote of, we are the crew of Spaceship Earth and we're in mutiny. If we
on an organic spaceship.
If we could look at ourselves in that paradigm, it would probably help a lot. I mean, I think if more people saw and believed just how frail the Earth.
Yeah.
Which bring out this.
Yeah, let's get those out. I wanted to see that.
So this is the Earth, right?
Let me see that.
And it's got a little stand there, and this is a really kind of.
Man, dude, that is cool.
It's kind of a bad moon. That's not, but the size is correct. And
is the continents and everything like?
It's
perfect.
It's not perfect.
It's gotta be perfect.
It can't be perfect, but.
Probably the
I will tell you this, that is a fairly accurate representation topographically. Like that you feel you feel the little
Shouldn't it
ridges.
be white up here?
It's summertime. Get over it.
It's summertime.
No, this is the Earth 10 years from now when there is no Arctic.
Exactly. There we go. That's it. That's all that's left right there.
The depth of the oceans at this scale is measured in like individual molecules. It's like 17 molecules deep. The atmosphere at this scale is, if I put a piece of paper to this, it's the piece of paper is way thicker than our atmosphere is.
Yeah.
And
That's
so
wild.
we don't live on this.
Right.
We live on the film. The paint that they use is way thicker than the mountains actually are.
Yeah.
And so we're living in the paint.
It's kind of like the apple
scale.
and the apple skin thing.
Exactly.
Is that kind of?
Yeah. Which the apple skin is roughly as thick as the atmosphere.
Okay.
So everything, and we're in the troposphere down here. Like that's what we like really need. And we fly in the stratosphere, and then there's the thermosphere and some other ones. But that apple skin is all of that.
Right.
We're just down here.
We're living in that apple skin.
But we're on the bottom of the apple skin.
Right.
And going, you can't hurt the apple skin. Drive as many cars as you want. You can't hurt the apple skin.
Right.
Well, the truth of it is the apple skin is thinner than you feel.
Yeah, you just can't see it because we're so fucking small.
It feels big, but
let me see these. What is this? The moon?
That's the moon. So we can do the experiment. How far away?
They got every crater on there,
do you
huh?
think? Nah, it's like 7. I'm not very satisfied with the moon. The Mars is pretty good. But how far away do you think the moon is from the Earth?
Oh, I know it's pretty. It's probably like something like this.
It's probably a little bit further, but
you're a little bit further. I
know
so I know someone would be like that.
Yeah,
I know it's far.
So it's 30 Earth diameters roughly. Okay. So if you think of 30 of those, I mean,
okay, it's out there.
It's probably out here or something.
Right.
And what you can do is if you put the Earth where your eye is, and now you just make the moon as big as the moon is in the sky, and you've got it right. And the moon's it's about that or so.
Yeah, for sure. These are cool, man.
Yeah, I like them for science.
All right, so let's see if
So
you can
then
do Mars
So
with
then you
your hand.
say, okay, how far away is Mars? And it's out of your subdivision. You know,
Right.
It's a mile
You
down
think
the
it?
road.
You think so?
Well, depending on where
How
Mars and Earth
how
is in
far is
orbit.
Mars from this Earth? Like, can you give me a unit?
Where's the slide rule?
I want to know.
Sand here,
well,
isn't
so no.
Like a mile or something like that? You think?
Yeah, well, and see, there's times when the Earth and Mars are closer, and there's times where they're farther apart.
Yeah.
Because
Right.
the Earth is here going around, so call like this guy the Sun. There's times when they're like this, call this Mercury.
Okay.
So there's times when they're both here
Right,
and they're
right.
close, and this is called opposition.
Mhm.
And this is the best time to look at Mars. If you look at Mars in the weeks of opposition,
Because of
is
the
when you
sun's-
can see the
sun's
polar
light.
caps. You can see these different. You can actually watch Mars rotate over the course of those few weeks.
Uh huh.
But then there's times when Mars is over here,
Yeah,
over
yeah.
here, and it's close to the sun. You probably can't see it, but even if it's over here, this is a much larger distance. So
Right,
Mars goes through a huge, like Jupiter's always far away. It goes from far away to really far away.
Yeah.
But like Mars goes from 50 million miles to 300 or something like that.
And like something like the Oort cloud is super far
Super
from
far
like
away.
Pluto, right?
Yeah.
Even from like the farthest
Yeah, the
planet.
Oort cloud is
And what is that made up
it should only loosely even be associated with our solar system.
Right,
It's
that's what I've heard.
It's almost just the interstellar medium.
Yeah.
Because the Oort cloud, of our star is probably touching the Oort cloud of another.
Yeah.
They're
Okay.
it goes out to like a light year.
And past the Oort cloud is what, interstellar space?
That's your like true interstellar
That's
space.
what I thought, yeah.
But the Oort cloud is so diffuse. If you were in it, you wouldn't know. Even being in the
What is
asteroid
it?
belt.
What even is
It's a cloud of comets.
Okay, that's what
But these comets, because you're so far out, the circumference of that radius is now so large
Yeah.
that this donut shape that you're defining as the Oort cloud, you could put 1 billion objects in it, but they're going to be so spread out
Yeah.
that you're never going to know you're in it.
right.
You're gonna sail right through it. You can sail right, like in Star Wars they go into the asteroid field.
Fuck Star Wars.
That's big money. If you go to the real asteroid belt and you're on an asteroid, you'd be lucky if you could see another.
Right. Okay.
It's
That's
so
how big.
diffuse.
Yeah.
You can see animations where, boy, it looks like a turmoil of stuff.
It looks
that's
like a
about
solid
to,
object. Yeah.
But each of those pixels represents like
It's just the same-
40,000 square miles, and so there's actually a lot of room in between those.
Is there a point where we can get where like our whole solar system looks like a single point of light? Like, is that
So
that would probably be out of our
so have
galaxy?
you heard of the parsec? It was used in Star Wars.
Yes.
Okay, so the
And it was used improperly in Star Wars.
Well,
I've
no.
heard that.
Well, some really clever people figured out a way you could make the Kessel Run work.
They
the
used
way
it as a
wanted.
measurement of time, right?
Yeah,
And it's not. It's
it's
distance.
a unit of distance.
Yeah.
But so, all right, Star Wars fans are gonna love this. So, say this is a black hole, right?
Okay.
So, what the Kessel Run is theorized to be, this is what like makes the Han Solo's numerical interpretation work, is the Kessel Run is not a race from point A to point B. It's a race from point A to point A. And so you have to go around this black hole and back where you started.
Okay.
Okay? But if you can't go really fast, going close to a black hole is a bad idea. So you have to take a longer journey to get back to where you started and go around the black hole.
Okay.
So that ends up taking you much further.
It's-
but if you can go faster, you can get really close to the black hole, and you could do the Kessel Run in under 12 parsecs.
That's what they were talking about in Star Wars, was a black
Well,
hole?
No.
Okay, I didn't think so.
It was most likely a mistake.
Yeah,
But
that's-
people found a really clever way of making it right.
Okay, that's what I was
So they said, hold on, if you made it a black hole and you said that the race was this, then maybe that's how
Yeah,
they
they
would
never
define
even
it.
mentioned a black hole
No.
once in Star Wars.
So is it -1 times -1 is -1?
Yeah, exactly. It's people that do fan theories think so deeply. They should really go into the
They
science.
should really go. They should go outside. Is what they should do.
I don't know, man. Some of those fan theories are just like, wow, I love how they can take a defined, rigid story, and then, they're basically conspiracy theorists, but they're doing it for fun
fiction,
instead of doing it to ruin everything. But saying, oh, if you misinterpret everything that this guy says, then maybe this is what's going on. And it's like, wow, that's really interesting,
Yeah.
But we were talking about. We weren't talking about the Kessel Run. We were talking about something
Star
else.
Wars, man.
No, it wasn't Star Wars.
No.
I brought up Star Wars.
You were talking about parsecs.
Oh, a parsec. Okay, so
Yeah.
what a parsec is the distance that you have to travel away from the sun, so that the distance from the Earth to the sun becomes 1 arcsecond.
Okay.
So it's a geometric exercise where I say, okay,
How far do I got to
here's the
get
distance.
before they look like they're one thing?
They're not one. Well,
They
yeah,
look like it, though, right?
By your naked eye, you'd never see the Earth at that distance.
Well, it's kind of like looking at like binary systems and stuff like
Yeah.
that in a way.
So it's the distance you have to go before the distance between the Earth and the Sun
Yeah.
become. Is it 1 arc minute or is it 1 arc second? Now Google it. And it turns out it's like 1.1
Jamie,
light year,
Google it.
like 1.4 light years or
Laptop's
something
way
like
too
that.
shitty.
Oh, I bet.
So it's right around the light year.
Okay.
It's just a different unit astronomers came up with that has some sort of formal definition.
Mhm.
A light year's pretty good, but the reason a parsec is interesting is when you talk about stellar parallax. So the Earth going around the sun. Now Mars is the sun. So when the Earth is here looking at a star, it's going to measure an angle. And then 6 months later, when you're over here, you're going to measure a different angle. And that's called your stellar parallax.
Okay.
It's an extremely small measurement.
Okay.
And so basically, a star that is 1 parsec away will have a stellar parallax of 1 arcsecond.
Okay.
And I'm really hoping I'm not screwing it up and it's an arc minute. I want to say it's a second. So if an astronomer says it's got a stellar parallax of 0.5, it's 2 parsecs. So they're kind of inverse related. And so to an astronomer, a parallax measurement can instantly be easily converted into a distance. And we can't measure the distance to stars in light years directly. You can't look at the light and say, oh, this light's 4 years old.
Right.
You can't do that. You have to do it through parallax or other types of red shifting and that kind of stuff. So the parallax, if you're doing parallax measurements, is really useful because you can turn it into a distance really easily.
It's heavy, man.
Units are there's weird things that happen to math when you apply units to them.
Mm-hmm.
It's just sometimes it muddies it up, and sometimes it's you have to.
Mm-hmm.
If you don't, which is why we really need to get on the metric system in this country.
Yeah.
Like it's so much better for so many things. I
Right.
mean, there's no field of research you're going to be able to go into that's not using the metric system.
Right.
They
It's more
they
optimal.
convert between each other so much better because they're all unified under one framework of the base 10,
Right.
which ounces.
Yeah, 10 fingers, like.
There's 16 ounces in a pound, so that's a base 16 system.
Right.
But
And
the next
it's just,
step up's different, right? From pounds to
right, yeah,
tons or whatever.
right. You can't use the same. So the metric system converts really easily. Where I tell you it's 14 kilometers, you instantly know it's 14,000 meters.
Right. It's just.
Where I can tell you something in miles, you can't. If I say it's 5 miles, you're going to need the slide rule to convert that into feet, because it's
Right.
5,280 feet by 5 miles.
Right.
So the conversions just, you're sitting there converting things all day long
Yeah.
rather than just boom, it's done.
Yeah. Why do we even come up with that?
Oh man, Americans are just so afraid
Yeah.
of a little bit of work.
Yeah.
You know, why does nobody get outraged at the 2-liter? 2-liter seems normal. That's a metric unit, a liter.
Oh, okay. Yeah.
You know, but man, you put milk into a 2-liter, people will lose their mind.
Yeah.
They will
Yeah.
not know
We got 2 liters of milk here.
How-
What the
how-
fuck?
how many bowls of cereal is this gonna make. I have no idea, and I don't know how to convert it. You know, and
Yeah.
it's like, jeez.
You know how many bowls of cereal a gallon will make?
17.
Just got it figured out.
Yeah. What's that about statistics being just made up on the spot?
Oh yeah. So
But,
we're gonna see you. You're gonna be working for NASA in a couple years then.
It's probably gonna be more than a couple, but yeah.
3, 4 years.
Well,
It's
so
a journey.
So I'm trying to get through, get my bachelor's, and then I want to do, go to graduate school at Purdue,
Okay.
because I hear a lot of astronauts come out of Purdue. So
Okay.
that's kind of the goal.
You want to be an astronaut?
I want to do spacewalks.
Okay.
So specifically, I want to work on.
That's Schlitter, man. Schlitter wants to be an astronaut.
Yeah.
Yep.
I don't like them.
You don't like him? You guys are
like 'em.
competing. We'll have them both on together,
It's-
dude. That'd be great.
It's cutthroat, you know.
You guys will fight for air.
Yeah.
Awesome, man.
We'll see what happens. I mean,
Okay.
every great scientist I research or whatever, a lot of them they went to school and then they found this interesting little thing, and then I fiddled with it for a while, and all of a sudden I figured out about like the Mandelbrot set and fractals and stuff like that.
No.
The Mandelbrot set is amazing. You know, it's you can't not know it. If you saw a picture of it, you go, oh, I've seen this.
Yeah.
It's it's like a cardioid with like another bulb, and then but you can zoom into it forever.
Okay.
It's this fractaline structure that just keeps going.
Okay.
And Mandelbrot, he was a naturally gifted mathematician. He could see geometry in a way that it was very intuitive to him.
Mm-hmm.
But he like went to school and was working on something, and then I could apply and he basically invented chaos theory. But he didn't set out to invent chaos theory.
Mm-hmm.
He just stumbled upon it.
Right.
And it's this thing that like now we can do so much based off of understanding those kinds of systems.
Yeah.
Probability and that kind of stuff that a lot of people, like, everyone hates statistics. Like, I just...
Me?
No, I was just looking at you, and you're just
I'm listening.
you're just staring at that
Focusing.
thing.
You can't focus on your visuals.
No.
You're focusing on your hearing.
Yeah, that's so true.
Anyway,
Like, especially when you're talking with like numbers,
you gotta really listen.
you gotta close your eyes. With me, it's just like my head's spinning this
Can
whole
you...
time.
So this is an interesting... We'll just sidebar here. So, when I say orange, do you think of the color orange,
Yes, I just thought of the color.
the
orange.
word orange,
Out of the fruit.
or the fruit orange?
I thought of first the color, and then it's like zoomed out.
Okay,
And
so,
it was the fruit.
but in your mind's eye, do you physically see orange?
Yes.
Okay. As real as this is orange?
Yes.
Okay, see,
I
that
just did.
fascinates me, because, like,
I
when I
did.
close my eyes, I don't, like, if I imagine a
Okay,
cube,
now when I close my eyes, I don't. Is that what you're talking about? Closing your eyes?
Yeah.
Oh, when you said
I said
when you
cube,
said orange,
yeah.
and for some reason in my head I just saw orange.
But do you
How did I
literally see orange?
I guess not, because I was
Okay.
looking at you.
Okay.
So I guess
Because,
not.
like, I hear, like, I've met people that say they're literary people, so they see the word.
I saw that when you said it. So yeah, I saw orange.
So I'll be like, okay,
Yeah,
I'm
yeah.
going to say this word, and they say it goes across my vision
Ooh.
in a certain typeface.
Hmm.
And there's
Orange.
people that experience the world like that. If I close my eyes and visualize a cube, I can visualize a shape, I can rotate it in 3 dimensions, but I don't literally see it.
Yeah.
You know what I mean?
See,
More
like
abstract
when
than
you
that.
said cube, I saw a sugar cube. Like, instantly, man.
The words
but you
sugar
didn't.
cube?
No, I saw a sugar cube.
But you didn't literally see
Exactly,
it.
right,
Okay,
right.
see, it's a, and I almost don't believe these people when they say they literally see
They don't,
it.
though.
Because I go, do you know what I mean when I say literally? I mean you actually saw it.
Well, no,
right?
they
And you
wouldn't.
go, no.
Because light would have to travel from some fucking thing into their...
Well, okay, so maybe not
Literally.
literal in the
You're,
most
it's
extreme.
from your head. It's coming from your
But
head.
are you seeing it? Because, okay, so like when I go to sleep, I meditate.
Yeah,
I
man.
meditate as I
Totally.
fall asleep. And so a lot of times I can get these really cool
Yes.
swashes of colors.
Yeah, I get
So,
like
like,
hallways is what I
okay.
get when I meditate. Yeah.
That's the only time I physically see something.
Yeah.
And I've done a lot of practice in like lucid dreaming and stuff. So like there's been times where
Mhm.
I've been able to transfer from this like weird just color flow to actual dreamscape.
Yeah.
But it's extremely rare for me. But I struggle to believe that like people literally see the word scroll across their vision. Like when I say close your eyes,
That's
and
what- that's
I'm
an interesting
gonna,
thing
and I'm
about,
going to
yeah.
say baseball, and you're going to physically see the word base. But some people must, because the people that can like flip words or find
Ooh.
like anagrams or whatever,
Yeah.
the you know, like what's
Yeah.
it called? There's a word for like you've got a sentence and you can rearrange the words into another, or letters into another sentence.
People can do that.
There's people that can. Like Weird Al is like one of those people.
Yeah.
Like, he has a video, and I can't remember the name of the word, but the video is called like that word, and he's made this Bob Dylan type song of
Mhm.
all these, or no, they're phrases that are the same front as they are back.
Mhm.
So like race car is the only example I can think of.
Yeah, I don't
Like
remember
race
the
car
name,
is
no.
the same forward as it is backwards.
Oh yeah, it is. It is
He made all of his lyrics go forward and backwards.
Wow.
And it's the most it's nonsensical, which makes it sound exactly like a Bob Dylan song. But
oh, I just
how you come up with all of that is just crazy to me, because my mind does not work in words like that. Like I can't do.
Your mind works in numbers. That's what it is.
My mind's great with science and physical objects and in 3 dimensions and stuff like that. But you give me a word problem, you know, like the jumble. I'll sit there for 4 minutes trying to figure out what word you can make with this jumble of letters, and then some people just walk up to it and go, "How can you not see what word that is?"
Yeah,
you know?
yeah.
And it's just very interesting how.
That's the same
different
thing,
the
just in a
brains
different
can-
way as the mathematicians.
Yeah,
man.
just brains are different.
Yeah.
It's different.
Yeah, I mean, you're seeing this room and everything in us in a total different way than we are. You gotta be.
But how different?
Oh,
like this
how
is the
can I
whole
know?
like is your red my red debate.
Yeah, exactly. What does
I
that
know.
look like to you?
And see, I feel like there has like from I try to break things down. Like if we're talking about like humans, everything's from an evolutionary standpoint.
Yeah.
Like so from an evolutionary standpoint, I feel like there has to be continuity between all of us creatures. They all came from the same place, because I think it would really muddy our ability to work together if our color spectrums were completely arbitrary.
Yeah.
Like, if color was just, because you can show that like red is an aggressive color and blue or green is a calming color, and like green
Right.
is the color that we're the best at sensing. Like you can see more greens than any other color, and it's because of that's where our sensitivity peaks in
Right.
the spectrum.
That's evolutionary.
It's
Probably from
evolution.
trying to
And the
pick
other
out
thing is that
different
like
plants.
color,
Totally.
in a sense, is real and not real at the same time. Like, this is not red because the atoms are intrinsically red. It's red because of the spectrum of light that it reflects
Yeah,
and
sure.
absorbs and all that. But red is a real wavelength of light.
Yeah.
That's true.
So it's,
But the question is not what the wavelength is, it's what does the wavelength look like when you
right,
see
yeah,
it.
when you interpret it.
Exactly.
And I would be willing to guess that there's
They're probably
there's
pretty
definitely
similar.
differences, because there's people that are colorblind, and
Right.
but we were able to figure that out.
Yeah, we got those
You know
glasses
what I mean?
now.
Like, and if you can figure out that, I mean, how did they figure out that the one guy couldn't really see red, but we can't agree whether red's the same.
Yeah, how did we
You
figure
know
out
what
there
I mean?
was even colorblind people?
Right.
Yeah,
So see,
okay, I see
they'll
what you're
see
saying.
this and they'll be like gray, right?
Yeah.
Like
Or something.
But
It
how
would
do
be a
they
darker.
explain that to you where they say,
Do
no,
these two
no,
look
no,
the same?
I guess.
Yeah, that's what they would do. They'd say, "Oh, well, these look the same,
Yeah.
and these look the same, but these are different."
So really, the
And you'd be
argument
like, those
is
are all
so
different
you can be colorblind and things look the same, but the argument of what red is that there's still a distinction between these two things, but the
So it doesn't
distinction
matter.
is different.
Okay.
Like 2 is 2 units away from 4, and 4 is 2 units away from 6. So you might be seeing 4 and 6, and I'm seeing 2 and 4. They're different things,
What-
but they're still the same
Difference.
step away from
What was
each other.
that? Do you remember that picture on the internet?
the dress?
The dress. What was?
Dress.
I never.
I didn't
What
get it
happened
either.
there? What was going on there?
I don't know.
There was
a
a picture of a dress, and like they were like, "What color do you see?" And everybody was either saying
Yeah.
gold or like,
Yeah.
no, I forget the other color.
I think it was just. I think
Is
it
it
was
like pink and red? Like something similar?
Yeah, it was weird.
No,
man.
it was really bizarre. But there's really interesting optical illusions that you can get because of how your brain treats lights
Yeah.
and shadows. That, like, it's
Oh,
almost
cool.
not even interesting to me because it's, first of all, it's meatbags talking about the color of her dress. I'm like, okay, big deal. But you know, I think a little bit of it was expectations, like, you know, they were kind of predisposed
See,
to
for
like,
me, though,
see a certain color.
For me, someone was
yeah.
just like, "What color is that dress?"
Yeah.
And I was like, "I forget what color I said," and they're like, "Really?" And I'm like, "What? What's wrong with me? What's going on?" And they're like,
Yeah.
"Yeah, everybody's talking about
It was
this."
it like
Yeah.
50-50 split?
I don't know what it was. I don't think it was.
It existed right on the cusp where your brain could easily see
Uh-huh.
it as
Yeah.
a bright color in shadow or a dark color in light, and so you could just eat.
So
I
depending on the
flipped.
setting of where the picture was taken of the dress,
Well,
maybe it was light in the background. But
I
some
could
people
flip.
didn't see
I could
that.
flip back and forth.
You don't think that's interesting though? That fascinates the shit out
Yeah?
of me. Yeah, oh yeah.
I mean,
You're seeing a different color than I am, and we know it for sure. Like that.
But have you seen the thing where they have like the tiles that are shaded, and they point to the white tile and they say that white or this black tile. And let me sure I get it right. This black tile is the same color as the white tile that's in the shadow, and people are like, no.
I've
And
never
then
seen that.
they physically pull the tile up and put it over, and it literally changes colors as you move it
I've
across.
never seen that.
Oh, it's trippy.
Where do you see? How do I see that?
The internet.
Oh, let's get on that. I want to see that. We'll do it after.
Yeah, I'm trying to think of like what you would search, but it's like it's a color illusion. It's
I wanna see that.
it's a very well known color illusion, and it's because your brain is so predisposed to interpret shadows
Yeah.
that if you play with that in the right way, you can force people to see the wrong color.
Right.
It's the same with like they can produce images that have no red. They're only composed of blue and yellow pixels.
Okay.
And they produce an image of a strawberries, and people say they look red. And it's like, well, there's no red in that image. And
Right.
people go, but
Yeah.
strawberries are red, so your brain just
Yes,
wants
yeah.
to
It's
see
just a
them that
pattern.
way. You know,
Yeah.
your brain doesn't do well if it can't make sense of its reality. And so your brain goes to
That's religion
amazing-
right there.
Right? No. It's the opposite of religion.
Well, no, that's why religion started, dude. Because we had all these
No,
people.
religion started to answer unanswerable questions.
Exactly. That's my point. Like, what was the biggest question? What the fuck are we? The humans were walking around not knowing what they were,
Yeah.
why they were here, and that did not go well upstairs. So
Well, see,
things,
and that's
a very
you know we didn't
simple
talk
explanation.
about AI, and we probably should, because I'm really curious whether AI will have some sort of religious experience. Because
like a spiritual.
I have a hunch that that this will be the hallmark of consciousness. That consciousness has a really hard time dealing with its own mortality.
Yeah.
And it doesn't matter what that consciousness is. So
So you don't think
the
that AI,
computer-
if the AI is conscious, it's gonna deal with mortality?
It's gonna have some
I haven't
sort
heard
of.
that before,
It's not. If it doesn't care, I kind of like. I don't like that.
You think it's consciousness
Like
that?
when I hear people say they're okay with with their mortality, I'm either I
Yeah,
don't
dude,
believe you.
That's Schluter.
I either don't believe them,
Yeah.
or I'm just kind of like, ooh, those are the people that cut.
Say that.
Those are the people that like cut people up in the middle of the night. You know what I mean?
Yeah.
Like
No
you've got
consequences
you've got
of
a
anything.
disconnect
You see,
there. You know?
I would say it's either consciousness or emotions that trigger that. Because an AI is it going to have
But-
emotions?
One of the I heard a great quote listening to a panel on AI, and they said the problem with computers is they're too aware. It's not a problem
Exactly.
of awareness. They have
Filtering.
they have an over awareness. They can remember everything that happened to them in excruciating detail.
Yeah.
And that's probably not what you want. You need to discreetly remember things and have, we exist in a very weird, we're in the now, but we have memories and we can think about the future, and so we can exist in our minds in all these other places.
Yeah.
But we have a physical reality as well that we don't have power over.
Right.
And so in that definition, like if you're trying to get a computer to be what we are, because I think computers are already more aware than we are in other ways.
In other ways, yeah.
But-
They're not aware of
Well, and
life
but-
in a way.
because a lot of people use self-awareness as like the word for the pinnacle of like, okay,
Enlightenment or
an
something.
AI a computer is conscious when it becomes self-aware, and that's
Right.
No, because there are computers that are self-aware, but we wouldn't think of them as conscious. You know what I mean? There's learning machines that can learn how to
But do they know do they know? Are they just
They can't really
reactionary?
make
Well, that's the whole
sense of
thing.
the
Is
data.
there's a difference between self-awareness and like self-awareness of self-awareness, and then you just
Okay.
go down the rabbit hole of like I'm aware that I'm aware.
Am I
that
thinking,
I'm
or
aware
am I
of
like
aware.
thinking that I'm thinking?
Yeah,
Yeah, it's fucking stupid.
it's really no, but it's really hard to figure out if you because there's
Yeah,
there's
yeah.
the machine paradigm that like humans are just a complex machine. That's all the brain. I like to think of like. My brain is just a coral reef that figured out how to walk around.
Mhm.
It's your brain could, if you could just make your brain work outside of your head, it would be the same thing.
Right.
There's a theory called Boltzmann brain, which is all these random particles out in space, in infinite space, where anything can happen because there's infinite space for it to happen.
Right.
These particles randomly came together in a conscious brain, and that's your existence. You think that you're on Earth having all these experiences, but you're actually just a Boltzmann brain floating out in the void of space.
Right.
And there's no real good way of refuting that, because your brain is nothing but inputs and outputs and experiences that you have a hard time proving are real.
Okay.
But for computers, I think it'll be interesting if they, because I've already seen like AI, and I don't really necessarily believe that they're as far along as they say they are.
I say the same thing.
But when an AI really does say like I'm afraid of you turning me off, and it's believable,
Mm-hmm.
that's going to be a really interesting moment.
It's afraid.
in
Yeah.
our journey along this cosmic.
So that's what runs us, right? Mortality and
yeah.
sex.
Yeah, it really is.
Well, and
What it breaks
it's
it down
really
to.
because you have to program those motivation. I don't know if you've seen like Ex Machina. It's a great movie.
Yeah.
Super freaky.
What's it called?
Ex Machina.
Okay, I'll check it out.
It's a
You
good
seen
movie.
It, Joe?
No, I've just heard really good
Yeah,
things.
it's a good
It's
movie.
recent.
Is it?
Yeah, a couple
Couple
years.
years ago.
Yeah,
Okay.
It's in the Grammys.
All right.
sure.
Yeah, let's check it out.
Yeah.
You can program a computer to have certain drives, and so the question is like, okay, if you programmed a computer to be, ambitious like a person,
Is that really ambitious?
but you didn't program it to kind of have restraint, what might happen.
Right.
But if you made a computer that's basically a person, also like say you made a conscious robot that's just a box, what's what does consciousness make of an existence that doesn't have any external reality? Like, if your consciousness just existed in itself and didn't have arms and legs and abilities to move, what would your conscious mind even make of that?
Would it be like if somebody was born and they couldn't see or walk?
Yeah, and that's like a really like, boy, that's a weird,
talk or
like, how do you,
anything
but then how do you, like Helen
Yeah.
Keller, like, how do you get,
But she could even walk and touch
yeah,
shit though.
and she
That's
could,
what
but
it was.
it was also like, how do you get her experience out of her? You know what
Yeah.
I mean?
Oh,
like,
totally.
Even like blind people or deaf people, like, how do you really understand what that existence?
Yeah, like
Just
a
like-
blind person. Wow.
Yeah,
That's just
that's
that's
like
the
my
main one.
biggest fear is like losing
Yeah.
my eyesight. Like, psh.
That would be brutal.
But it's amazing what
Yeah.
people do. You
Totally.
know?
There's an article. Microsoft was doing testing with AI and stuff, and what they were doing is that they had two different systems where they like launched them or whatever. They were running programs that were
Yeah.
supposed to be consciousness, and they could interact with each other and like that. And they gave them language. They gave them English language to communicate with. And in a matter of minutes, they started sending nonsense to each other.
Yeah.
But it was in a way that each computer could understand each other, but the people observing it couldn't make any sense
Yeah.
of the sentences that were coming about.
And,
So it's like,
and yeah, that's the other like really interesting and scary thing of
Yes.
AI is like once something gets smarter than you can't explain what self-awareness is to a monkey. And so once something has a higher self-awareness than you do, it can't explain that awareness to you because you're literally incapable of understanding
Yeah.
that kind of
it's
awareness.
like the next dimension.
And the scary thing is, so then that computer starts manipulating you, and you have no way of knowing if it's doing it or not because it's smarter than you are.
They just
it's
pulled the
aware
plug.
of more things. Yeah, someone was telling me that there's this computer that they like unplug every night because they're afraid of it getting too smart. And I said, I don't know if I believe all that. Maybe it's out there. And I don't know if it was Google or who it was supposed to
Some
be.
big
but-
dog.
Yeah,
Yeah.
and they said that, like, this computer like called this guy and was all like, oh, you should, they had it doing investment banking, and it was finding patterns that they didn't even ask it to find, and so then they got all scared or something. I don't know if it's a true story,
Yeah. But it was just aware that something was observing it, which is very strange.
but yeah, it's gonna be a weird, wild time to like, and it's also like ethically, because I've met a lot of people that tell me even if it's conscious, it's not, doesn't have a soul, it's not a human, it doesn't matter, you can do whatever you, and it's like, it's really elitist of us to say we own this, it's not alive,
Created.
and it's like, if
we're God to
if
them.
it starts, if you ever seen the movie AI, the Steven Spielberg, 2000 something.
Oh, God, I need to
It's
see
not a-
all these.
It's not a
I'm
great. It's not a
embarrassed.
great movie, but what's interesting is at the end, they're far in the future where the only things that are alive are robots. They're these like crazy, they're just made of nano machines.
Right.
And they find this primitive first gen AI that looks like a little boy, and they're like, we're really interested by you because you emulate the creator.
Oh, right.
And that's why we're interested in you, is because we're interested in the things that created us. Like they were, the robots didn't.
That's a cool idea.
Oh yeah. The
yeah.
robots didn't actually overthrow us. It just kind of happened, and now it's been so long that they're actually looking back at us like we look at the Romans and going, "Wow, how fat! How interesting is it that they came up with this stuff? Like they come up with us." And I
So
think
cool.
AI will have that kind of experience where it's like, "Wow, you guys were so amazing. You came up with us."
Right.
To me, if I ever get religious, it's that AI is just the next step. Like there's chemistry, so you have like the Big Bang, and then you have just this quantum field that allows you to have chemistry, and then chemistry allows you to have biology, and then biology allows you to have animals. And animals were a huge step up from single-celled organisms. And then animals allow you to have higher consciousness, and then higher consciousness allows you to have AI, or the next step in it's. I mean, if, like I said, if I get religious, there's.
What do you mean by religious?
Just spiritual or whatever you want to call it. Like I'm not I don't believe in any of that kind of stuff too firmly. But if I try to, the stuff that's interesting to me is like that it all kind of looks like the universe becoming more self-aware of itself.
Okay.
Like how I said, we are in the universe and of the universe.
Yeah.
And we're the universe being aware of itself.
Yeah.
You know, we like to think that we're separate from the universe and we're exploring the universe, but we are the universe.
Right.
And so that next step is just, you know, the universe becoming more and more aware of itself.
Yeah.
And bacteria can't do what we do, and we can't do what AI will do.
Yeah.
Okay.
You know, AI can go into intergalactic space and exist for billions of years and travel these huge distances. We can't do it.
Right.
Can also just get into the internet and learn everything about human history.
Well, and that's the other thing. There's
math and
wipe us out.
Yeah.
Once it finds out we're the problem here.
you know,
I've heard that too.
It's
They
odd
fix
to me
the
that
earth
they
and then
will think that. I think we'll make sure that doesn't happen. We're pretty good at covering our ass.
Yeah.
But there's a graph of free will. I don't know if I want to say free will. Say privacy over society, right? And so you can either have pure privacy, but there's no society. You live in the woods by yourself, and you live to live. Like all of your time is spent foraging and building,
right?
And you die at 30. Maybe you were happy, maybe you weren't. But then you create society, and every moment that society makes progress, you lose a little bit of privacy.
Yeah.
Okay. Fundamentally,
that is
you
so
have
true.
to.
That's happening. Yeah.
Okay. It can't be done any other way. Like you can't invent the automobile and have the same amount of freedom that you had before the automobile, because you had to determine where roads were and then make rules for the roads and all this stuff.
Turning at right angles.
Yeah. You have to make decisions about how you're going to operate this society.
Yeah.
And so progress is us traversing this graph. Well, if you take it all the way, eventually you get pure society with no privacy.
Yeah.
And that's the hive mind. That's pure interconnectedness.
Yes.
You have no privacy because I have access to your entire mind.
Oh,
and you have access to
that
everyone else's entire mind. That's
like
the
a fun
internet.
guy.
Yeah, see, that's a terrible life. It's terrible.
Yeah, but it's
right,
not
I know
it's
what you
not
mean.
life as
we
we're
know.
used to
Right.
experiencing it. But there's a point where you have to say, okay, we're on this path. I mean, we're on the path.
Right.
You have to decide if you want to keep going or not. Because if you don't make a decision to stop,
but
you're
you're
going
saying,
to get there.
You're saying it as if it's like an indefinite path, though, one way, or like you're just saying that like it's going to go this way for sure, right?
There's a graph, and all it is society over privacy, and there's the two extremes, and it's just a line between them.
How do they get this data for this graph?
No. This
What the hell? Where is this coming from?
This is a spectrum. This is like saying, what am I trying to say here? There's two extremes,
right?
And I'm suggesting that they're interrelated. So that's, I guess, my.
Well, then I would say that a balance is
stipulation.
Important then.
Right, so you have to make the decision to find that balancing point, and then impose rules to not pass it.
Right.
Because someone else will come along and say, no, I want to manufacture the Ebola virus. How dare you try to stop me?
Right.
And I can 3D print whatever I want. 3D printers and stuff like that. It won't be long before. So like take drones and everything. This is like the big hot topic on privacy right now.
Yeah.
Your the debate is, should you give up some of your privacy so that we can have the benefits of drones? And drones could benefit society in huge ways. If you have a drone continuously flying over a city, and they've done this, there's a company that did this in Fallujah and Mexico City, and then they tried it in like Toledo, and then Toledo found out about it and got all outraged. They flew continuously airplane drones over the city in shifts for days. And until something happens. And in Fallujah, it was, roadside bombs. In Mexico City, it was cartels. And in the example in Toledo or wherever it was in Ohio, some house got broken into. Well, go back onto the computer. That drone was watching that house.
Yeah.
See who drove there. Now go back in time and see where they came from. Oh, they came from this warehouse. Or they drove to this warehouse after they robbed the place. Well, let's go there and talk to these guys.
Well, if we're going to do something like this, that's where regulation comes in then.
Right. Well, the problem is that people are so scared about losing their privacy and Big Brother and these cameras that they just shut it down. No, we don't want it. They caught these burglars like this.
Right.
They could put a stop to so much potential crime.
Yeah.
And the whole thing is the camera could see a vehicle and the resolution down to like a person. It couldn't identify a person.
Yeah.
So if a person went into a building, you couldn't tell if the same person left the building, but it could track a car through the city.
Yeah.
Now, if a car goes into a parking garage, that causes issues. But the fear was that eventually the technology will be able to identify a person, and now it's racist, and people are going to use it for bad,
Well, and that could happen.
It could.
Right.
But that's the question, is the benefit of being able to stop, 60% of crime.
Right. Where do you want to...
Of violent, bad crime.
Okay, yeah.
They arrested like 100 and some members of the Mexican cartel in like 2 weeks.
Wow.
Because every time there was a drive-by shooting, they could track exactly where they came from and where they went.
Yeah.
And I mean, so how much, that fine line of, okay, where do we want this privacy society graph to be, and
right.
where's the sweet spot? If you ask the Amish people, the sweet spot was 100 years ago.
Yeah, it's just it has a lot to do with the person. It really does.
It's not an easy question.
Well, there's no answer to it either.
Well, I think you can't stop it because so the government has this right now, but in 10 years private individuals will have this. And so would you rather the cartel be able to figure out where everyone's going?
Right.
Or would you rather the police be able to figure out where the cartel's going first?
Right.
And so, you can try to stop these things, but it just delays it, and then the bad guys get it. I mean, a perfect example in like, the 1910s and 20s when these crime rings had machine guns and police had pistols.
Yeah.
And, that's when this huge arm race about what police should be carrying really started.
Right.
And, personal freedoms. And
yeah.
That's why I do physics. It's way more fun than societal impacts.
Political and yeah.
Yeah, political is even worse. I mean, yeah.
Awesome, man. Well, we'll do this again.
Okay.
We'll do this again.
Definitely.
There's loads we can talk about.
Yeah,
I
yeah.
can tell. So thanks for coming on, man.
All right.
Awesome.
Ha 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 ha!